right? I want to show that the prime factorization workspace that you completed applies to these questions with product rule, power rule, quotient rule, simplifying expressions. And so in order to do that, if you worked on the prime factorization workspace, it's the second one in the entire trimester. I'm going to focus on the 81 first, because I think I saw 81 was a question that you guys had to work on. 81 breaks down through the prime factor tree into, well, it's not even, so I'm not going to divide by 2, but I know it's divisible by 3. There's actually a trick. What's 8 plus 1? If you add the digits together, 8 plus 1, when you add the digits together and that answer is a number that's divisible by 3, then the original number is divisible by 3. Turns out 81, when you split factor 3 away from it, you're left with 27. 3 is a prime number, so it's done. But 27 is not prime. Can we divide 27 by 3? Yeah. Add the digits together. If the digits add up to a number that's divisible by 3, then 27 is divisible by 3. It turns out it's 3 times 9. And then last of all, we know that 9 is divisible by 3, so we're going to continue splitting it. Factor tree. These are the branches. Get the reference, right? These are the branches of the tree. Okay, there are 4 threes make up 81. So I'm going to rewrite the 81 as 3 times 3 times 3 times 3. Because when you put them in a calculator, all of these makes 81. Side note, that's 3 to the 4th. Okay, just to kind of connect it to exponents. What I want to do now is I want to take this x to the 5th power, and I want to use what exponents do. Exponents talk about repeated multiplication. So x times x times x times x times x. And then that lone solitary, there's a 1 exponent, but we don't have to write the 1 y. So I'm taking the entire top and I'm splitting it up into its factors, its prime factors, if you will. Do the same thing for the bottom. So 27 is, well, factor tree. 2 plus 7 makes 9. 9 is divisible by 3. This isn't even, so I guess I should acknowledge don't divide by 2, but it will factor into 3 times 9. And then 3 times 9 will factor into some more 3s. So 27 is really 3 times 3 times 3. And so that's what I'm writing right here. Now, because there is y to the 3rd power, I'm going to break apart prime factor all of these y's based upon that exponent. There they are. There's 3 of them. And the x right here, that single solitary 1x, technically means it has an exponent of 1. Put it on the bottom. What this is, from that fraction to this fraction, is the prime factorization of the entire top with the entire bottom. Now, if there's something that's on the top and on the bottom, they reduce, they cancel. So cancel, cancel, cancel. I almost canceled that 3, but it doesn't have a matching partner on the other side, so leave it alone. Maybe circle it so you don't forget about it. This 1x and this 1x, they cancel. Literally, the math is they become the number 1. This y divided by this y, or this one, just pick one though, means that those cancel. So we're left with 4 x's. We're left with 2 y's. This whole thing simplifies to 3x to the 4th over y squared. Thank you for letting me share that with you today.